Before we get started, I want to show you where you could get the hobbyist version of Fusion 360. This is one that you don't have to pay for unless you feel like spending $400 for a program. Simply go to, first step would be to go to the Autodesk website. There you would find the products page, and click on that and locate the Fusion 360 and hit product details. There you go into the Fusion 360 website, and you want to go to plans and pricing. And finally you want to go over to the Fusion Personal Hobby Use and click Get Started. And bingo, there's the page that you can go up and sign up for a free version of Fusion 360. There will be some stuff that you have to fill out, and I think you have to establish an account. But other than that, you pay nothing for this version of Fusion 360. And with that, let's continue on. Hello, my name is David Glenn. I am working on the first part of a series of videos that I'm working on to basically show off how Fusion 360 works and how easy it is to use. For the first lesson tonight, I am going to teach you how to draw a knob. This is a very simple object made up primarily of circles that combine to give you a little twist knob that you can put a bolt through and use it to tie up panels and stuff. I designed this to hold up the to tie in the panels on a cover for a compressor that I was working on, and it came up with a very simple but effective object using very simple items. And so here we are in Fusion 360. I just turned the camera up so we're staring down upon the object on the top, from the top down. And I'm going to start by going into the surface, which is what we got right here. And I'm going to go click, and I'm going to go and start a sketch. In Fusion, everything gets started as a sketch, and you go from there and you build your objects, based on that sketch. And so tonight we're going to use basically use a series of circles. And so I'm going to begin with this one, which I'm drawing out right now. Here's our first circle, and I'm just going to bring it out a little bit, and I'm going to set this. I'm going to go to the keyboard now, and I'm going to change the value that you see in blue in there. I'm going to type in the value that I want. The value that I want for this diameter is going to be 25 millimeters. So I just simply type 25, and I hit enter. And now I have a 25 millimeter sketch of a circle that you can see here. And from there, I'm going to go ahead and select the circle, and I'm going to extrude a cylinder based on this circle. And so what I'll do is I'll go into here and I'll right click again. I'll go down here to extrude. I'll hit the extrude item there in the spider menu, and go ahead and I'll bring this up. And for now, I'm going to bring this up to make it 10 millimeters. And there you go. We got this, the base of our knob, our little hockey puck here, and it is 10 millimeters high. It has a diameter of 25 millimeters. And what I'm going to do now is draw the bigger portion of the handle, which is going to be built on top of this surface right here. And I'm going to, might as well start off. I'll go back here, center this, select it again because I lost it, hit the right button, go to sketch, go to center diameter circle, go over here and click on this, and this one is going to be much bigger. It's going to be I'm going to make it 50 millimeters. Now, this is kind of large probably for a normal button, but for what we're doing here, I think this will do. And so now we bring it up here. We can tell that we got a sketch riding off the top of our hockey puck. And this is going to be the handle hold portion of our knob. And I'm going to go over and select this. Now, you notice when I select it that a ring appeared, and this circle is kind of broken into two parts. You got the center here, and then you got the ring. This is the consequences of you drawing something on top of an object. You will have this. Now you can click them both, hold the shift key and click them both, and you have selected both of them. Or you could go over here and just select this, and you would have selected the top of the hockey puck again, and or I should say the base. But I'm going to, I want to make a cavity which the bolt is going to hide into, and to do that, I'm going to click on this ring, and I'm going to go right click until I go to extrude again for the body and for the solid, and I'm going to go up a little bit, but then I'm going to go and say I'm going to make this, for the sake of argument, I'm going to make this another 10 millimeters. Now, something we have to keep in mind here, since we're building a 3D structure. As things stand right now, and I'll go over here and go to inspect, and we're going to do cut this in half so we can look at this, analyze this from a cutaway view. And you notice right away that we got, if we went ahead and made a print, or if we generated this knob the way it stands, that there would be an issue here as far as how of the integrity of the object. and it would be very obvious by looking at it right here. Basically, the top handle would probably rip off from the base, and we don't want that. So, I'm going to cancel this. I'm going to go in and go back down here and go to the pivot again, and I'm going to make sure I selected the top of the base of our knob, or the hockey puck, if you want to call it, and go back up to here, and I'm going to, with that, I'm going to go, I don't see it. It's not visible. Hang on a second. I'm going to go select this, and I'm going to go, okay, it's here somewhere. It was here. Heck, I'm just going to use the E key. I'm going to select the E key, press the E key, and that will force me into the extrude mode again. And in addition to the 10 millimeters, I'm going to bring this up another 5. And hit OK. And now we'll go over here and we'll look at this from the side view again. We'll do an inspect. We'll do a section analysis from this angle. And you can see now we have a lot more beef to the knob here. About the only thing I probably want to do is raise this up just a little bit. So I'm going to go over here and hit this. And I'm going to go, this time I'm going to hit extrude from here. And I'm going to raise this. It doesn't have to be much. Let's see. Let's make it another 3 millimeters. It should be enough. And so now we'll do an inspect. So we'll get things from a section, cut in half, and now we have a little more space. We want to put a cap, if we want to put a cap on this somewhere down the road, which I won't demonstrate in this video, but it's something that I've done. We have enough cavity here that I can install a cap over this to hide the head of the bolt, which is going to be right here. So go and hit that, and so there's our knob. Well, right now we got a pretty slippery knob, and I want to add some grooves to it to make it a little easier to turn with our fingers. And so what I'll do is I'll go back and I'm going to generate some circles, and with the circles I'm going to build, use those circles, use some cylinders to actually cut notches. Now, it's a kind of a strange concept to create an object to cut away an object, but that's the way, generally, how you shape things in Fusion 360, at least in the design mode. It's not that hard to do. Let's go over here. It's just like what we did when we made these 2 round objects here. We go over here, we go to go and hit right thing, go to spider, hit sketch. Oops. Right here goes sketch, create a circle. And this time I'm going to go off off the 25 millimeter mark here. I'm going to hit right there. I'm going to bring it out, and I'm going to make this 33 millimeters. And there we have the basis of our cylinder. We can go over there and select it. And I'm going to bring this over to the side here so you get a good view of what's going to happen here. We have our circle. I'm going to go here and do an extrude. Now, when I do the extrude at first, it's going to look like I'm creating a circle. I'm doing a new body. And this right here, it says new body over here in the menu. So as I go up, I will intersect with this object here, with the handle hold, and you will start to notice that this thing is turning to cut. And as I go around here, you can notice that I'm milling away at the upper cylinder of the upper ring. And I'll continue to do so until I get up to here, and you can start noticing the cut right about here. And this is the program assuming that you want to do a cut. This is what it does by default. Now you can actually go over here and you got different choices here. You got join, you got intersect, which is kind of useless, but it's there, and as well as just do a new body, which is basically just generating a new body that's intersecting with another body. What we wanted, of course, to do is cut, because we want to make the first notch of our finger notch for our knob. And so that's exactly what we're going to do. And how tall the cylinder could be, it really doesn't matter. It's just as long as you are cutting, going straight through this the handle. That's all we're really concerned about at the moment. And you can see the cut right there. So say, I like that. So I'm going to hit OK. And our cylinder will go away, and we're left with the absence of where it intersected, and we got ourselves our cut. So I'm going to go back here, and I'm going to do the same thing 4 times. And I'm going to start off here. Go sketch. Go center diameter circle. Go over and pick our surface right here. And go out. Type in 33. Go over, select this. And this time I'm just going to hit the E key, and I'll go to extrude, and then it will pop out, and eventually you'll see it cut through our handle hold here on our knob, and go plunk, and then go to the top, sketch, center diameter circle, plunk, plunk, and sometimes you'll and usually got to hit the thing twice where you want it in order to get get it in the space that you want, because that's where the center is going to be. You can tell Well, you can tell in the corner here where the sketch palette is that you can choose between various different types of circles. But we're sticking to a just a diameter generated circle for now. I'll make it 33, enter, select, extrude, and I'm going to move it over on the side here so I can see the arrow. I can just pick up the arrow and just drag it through, hit OK. Do the same thing at the fourth quadrant. Pluck that. 33. Select. Hit the E key. Go through and cut our little thing. Extrude and cut. And go over here and voila, you have the basis for your knob. There's your very simple little knob. Now the next question is, and next part of our lesson here is putting not just a, well, you know, it'd be okay to put a hole in this thing. I mean, that would be one thing we could do. But it would even be better if we can recess a bolt, a cavity that would precisely fit a bolt. And this is one of the times where Fusion 360 really shines. And I'm going to show you why. I'm going to go over and go into the Insert menu here. And you got it. One of the you could insert various other objects into this drawing to add whatever detail you want. But the one I'm interested in is insert McMaster-Carr component. McMaster-Carr is a company that generates everything from bolts to you know, they have welders, they have everything. They're a little bit of everything. They're like the ultimate hardware store. And one of the nice things about McMaster-Carr is with their components, particularly their bolts, their nuts, their bolts, their hooks, it also comes with a CAD drawing with it that you can incorporate it into your drawings. And that's what we're basically going to end up doing, is we're going to end up borrowing one of these CAD drawings from this catalog that they have. I'll click on it and you will see the catalog right here. I'll try to make it a little bigger. And we got here the website of McMaster-Carr, and we can select various objects here that more likely than not have some form of drawing. At least most of the items they have drawings that you can use in CAD design. In our case, what we're concerned about is the bolts. And we're over here. Here's a whole list of their bolts. They got just about every type of bolt that you could ever want. I'm interested in hex head screws, so I'm going to click on that. And I'm not too fussy, you know. I'm going to go pick a grade 8 steel hex head screw, which is more powerful than I need, but will do the job that we want to do at this time. And I'll click on that, and then we get a whole list of their partly and fully threaded bolts. And it's at this point that I can go over here to the little side menu here and define exactly what I want. And in this case, I want a 1/4 inch 20 thread per inch bolt. I want it to be 2 inches long. I want it to be partly thread. You'll see why later on. It'll of course be grade 8. It will be steel. And the head width will be 7/16. The head height will be oh, we get a choice. Well, let's pick the slightly larger. And there, we're down to one selection over here. And then we're going to go over here and say, how many, you know, we're not worried, we're not actually ordering anything right now, but we do want to see the product detail. We can click that right here. And we very much get a very deep detail, including a nice little draft drawing of our bolt. But we also get a downloadable 3D drawing or 3D model of our bolt that we selected. And for the sake of Fusion 360, I'm going to pick a 3D STEP bolt drawing. And I'm going to hit save. And the thing disappears. And our bolt, first of all, appears down here within the base of the drawing. It is rotated. We're going to fix that. It's in its own little separate class right now. We're going to have to go in here and turn it on. And I'm going to click on this. Oops. At least I'm going to try to click on this. I'm going to click on this, and I'm going to go in and move the bolt and rotate it. And what I'm going to do, you know, I got these little things over here that I can use to rotate the bolt any way I want. But I'm going to go here to the front. And for right now, I'm interested in just this right here and just rotating the bolt so it's straight up and down at a 90-degree angle. And then I'm going to go over here and I'm going to move this thing so it's kind of dead center. I'm going to use the guides to kind of eyeball this thing in here. And then I'm going to go over to the top, and I'm just going to make sure that this thing is center to the top here. And I think this is about as center as I'm going to get it. It's at 0, 0. And Z is 0.54 millimeters. I'm going to go over and bring it down here again. I notice, well, it's a little north of where I want it to be. And so I'm going to bring it down to roughly here. And I'm going to go over and go and turn it around and say to myself, well, I could go a little further south. What I'm shooting for is to make sure that this stays above this surface that you just barely see here. So what I'm going to end up doing is selecting the object as the subject of what I want to cut and using the bolt as the cutting tool. And I want to make sure that this ridge up here is above the surface line, which is right here, which is part of this right here. And as far as I know, everything looks cool. I'm going to click OK. So we have our bolt placed in our knob. You can see that we are ready to cut our hole. The nice thing about using these particular bolts is, you know, bolt is pretty standard. So we could use the bolt that we got from the catalog. And in fact, the catalog number is right here if we need it. Or we can use anything we can get from any other source like Home Depot or your local Ace Hardware or whatever. And use that bolt, but it should work for this knob no matter what. But first, of course, we have to cut it. So that's going to be our next step, is to go into here, go back into our knob here, because this is set up as its own body, which is going to be great because that's what we need. Go ahead and go to the top. Now I'm going to use the combine tool. Now it's kind of strange to think about using combine to cut, but that's generally the nature with Fusion 360. Is you often use a object to either add or to remove in the case of what we're trying to do. In our case, we're trying to create a hole using this bolt, and we're going to do that using the combine tool. Now under combine we can either join, we can cut, or we can intersect, just like I've showed you earlier on. And then we also have to do a combine. You have a target object and you have a tool body. Well, in this case, this is going to be our target body is our knob, and our bolt is going to be the tool body, the item that we're going to use to cut the hole with. So we'll start off by clicking on this. And sometimes when you click on this, you'll get a thing that says, oh, the position has changed. But you want to use whatever is there at the time. If you don't want to change the position back to the original position, and I just say continue using or calculate using the existing condition. So we're going to keep, in this case it didn't come up, so I'm not terribly worried. But the next thing I'm going to do is choose the tool body, which is right here. And you can see right off the bat, I'll rotate this thing so you can see it. We are ready to cut a hole. It's already determined that it's cut the hole, and it's done all the calculations, and it has literally cut the hole for us. All we need to do, and hopefully this will work, is go over and hit OK, and we got the hole for our bolt. So technically we have our knob with all the specifications that we need. Now I want to add, purely for cosmetics but also to make it a little easier on the user, I want to add a chamfer, and I also want to add a fillet. And we'll start by adding a fillet to the top. And I will go up to here and add fillet, since the fillet will work on the edges, and we can very conveniently select the edges over here. I'm going to go over to the top here. As I said, I was going to go to the top. There we go. And hit one edge, and it turns blue. And hit the shift key, hit another edge, and another, and another, and another, and another, and another, and another. And there's two ways to invoke the fillet command. You can hear, well, actually three. There's they got by default they have the fillet command up here. And the other thing that you can do is you can just hit the key F, and it will go in and do the fillet. And out of trial and error, I found that if you set the fillet to 4.5, and I'm just going to do it up here because you got 8 edges and it's already selected, that that is adequate for the knob. And you can see we have a nice round top. It'll be much easier for you to grab that knob and turn it. Now I'm going to go around and hit chamfer. And to do that, I'm going to go to the bottom, and I'm going to hit the edges for the bottom. Start with this one, it'll turn blue. Hit shift, hit another edge, another edge, another edge, another edge, another edge here, and another edge here, and finally the last edge here. And I have selected the edge, bottom edge of our handhold for the knob. And then I'm going to go over here to modify, and right down here is chamfer, and I'm going to hit that. And what I can do is take the arrow and bring it down to here, but I want to make things uniform off the bat. So I'm going to make this 4.7. I'm going to give it a little deeper chamfer, and I'll explain why. I'm going to go do this. You will see why. There you go. You got the bottom edge. You got something you can go under and grab. But there is one more thing that is probably not quite obvious to you, but is quite obvious to people who do 3D printing with plastic. A large amount of the time, this section here, which in the 3D print is being created in thin air, has to be made using basically the nozzle just keeps drawing plastic out there until something catches. And the only alternative is that you make a thing called the scaffolding. Well, the thing is, if you go the scaffolding route, it's quite adequate because you get a relatively smooth surface down here. It's smoother than if you didn't have the scaffolding. However, it's going to eat up some of your plastic. If you go and build it without scaffolding, you're going to see a lot of lumps appear down here, and you're going to have to sand those off eventually. That will be the end result. By limiting how big this is, I cut down on the amount of scaffolding that I'm going to need and or lumping that's going to occur down here. Because when it gets to these chamfers right here, those are much easier for the printer to print. It's easier to build on build on a curve like this when it's like so. It's easier to build on this little curve over here with your nozzle than it will be to do go all the way out to here and then go up. And so we want to keep that. So we got here our completed knob. Let's go ahead and save it. Or in my case, this was already saved before, so I'm just saving a variation of it. And then one of the things I want to show you is how to prepare this knob. So it is ready to be 3D printed. And I'll go over here and we'll go up to File, go down to Export, and I go over here, and this is the way the knob was, the original name of the knob when I created this project. Right now it's saving it as an Autodesk Fusion 360 file. I want to change it down to something that the printer can understand. And I could also use it for other stuff, so I'm going to go over and make it an object. And I'm already directed to the proper location where I want to print it. I won't bore you with that. And I'll go over here and I'll hit Export. And as you can see before, I've created this knob, and I can go over to the printer and go over to what they call the slicing software, or what's called CURA, and I can show you how this knob is cut and explain to you a little bit about scaffolding and the such over there. I will go over, I have in fact the knob over here, I could just bring it over and drop it in our scene here. And you can see here is our knob as it was before. And look at it, and you can see the way it should look. This is without the scaffolding, and it's going to take 2 hours and 31 minutes to create this knob under PLA using a normal print. I can go from a fast print, go that to a fast print, which is only 1 hour and 5 minutes, which is a very crude version of this knob. It would work. It would just be much cruder, and that will only take us 1 hour and 5 minutes. Or I can go to high quality. Well, it gives you a very well detailed, very smooth version of this knob, and it will take you 4 hours. Now, I don't know if you want to take 4 hours to build a knob. It's up to you. It makes a pretty nice knob. Very little cleanup. But I'm just going to pick normal, because I know it's going to be just enough, just adequate for my need for this knob. It's just going into just going to hold together the panels on a tool that I have in my shop, so I don't need to be very fancy with it. Now, one thing I can do here is, since I'm building this thing right now, the way you see it, it's being built without scaffolding. And you can see that it's going to take me 228 layers to build up this knob. And this is kind of like a fast motion, a quickie about how the knob would be built, along with the internal framing inside. They do this basically in order to cut down on how much plastic it uses and still maintain the strength in the knob. PLA in itself is pretty strong. And then I'm going to do something a little extra. I'm going to hit this button over here, and it automatically prints a support structure, which goes underneath. And you can see the support structure right here in sort of like the aqua color over here. I'll go down here, and you can see how the support structure is printed. It's just a bunch of lines. What that is also referred to as scaffolding. That gets removed when the button or the knob is complete and gets thrown away. And by adding that, it adds about 5-10 minutes to the printout, which you may want to do. But for me, I'm going to just cut the scaffolding out. Just print it like this. In the end, it would be kind of nice because I can go over here and just literally grab the knob, and it will snap off the base of the printer. So with that done, I can go over here to File and save it as G-code. And go over here, and I'm going to go over to the tutorial and save this accordingly. And now I've saved it in G-code. G-code is the CAD/CAM language which the printer understands, and it will go off and print this. And that I will not show today. It'll be a subject probably for another video if you wish. But that basically concludes my video presentation. If you like what you've seen and you'd like me to make additional Fusion 360 models, I do have a model of a box for a light that's coming up. It has holes for a stem, for the stem of this flexible end of the light. It also has a hole for a switch and a plug that you plug a charger into the light in order to give it power. And if you'd like to see that at some point, let me know and I'll post it on YouTube. So that's about it. You have a nice day. Take care and be safe. Thank you.